Hello and welcome back to Math 8. This is a video over Section 3, and what we're going to be doing is we're going to be using the concept of substitution to solve systems, okay? And that's our objective. We're going to use substitution to solve linear system. So substitution means replace, okay? So it's important that we understand that word replace. We're going to replace things in various equations. So the first thing we're going to do is we're going to be using substitution when one variable is known. And here are the steps that we're going to use, okay? So we're going to use substitution to create a one-variable linear equation, solve to determine the value of the unknown variable, write the solution to the system of equations as an ordered pair, and then verify the solution. Okay, so what we're going to do, that first step is use substitution to create a one-variable linear equation. So what I'm going to do is here's my system, okay? Now, we have the equation y equals 2x plus 3. We also have the equation y equals 7, okay? So what I want you to note here is that this equation is solved for y, okay? And what that means is that we know that y equals 7. Okay? All right, we've already done half the work. Okay, we already know what the y value is. What we want to do is we want to now solve for x. Okay? Now, in order to do that, what I want to do is substitute 7 in for y. Now, how I think about it is that y is equal to 7. Now, what I'm going to do is I'm going to take this value here, or this value here, y equals 7, and I'm going to replace y in my other equation with 7, okay? So here's what I'm going to get. I'm going to get the value of 7 is equal to 2x plus 3. Now, what I have done is I have replaced y with what it was equal to in my other equation, okay? And so all I did was just, instead of writing y, I wrote what y is equal to, which is 7. So now what I have here is I have a one-variable linear equation. Here I had two variables, x and y. Here I only have x. So what I'm going to do now is I'm going to subtract 3 from both sides. And I'm going to get that 4 is equal to 2x. And I'm going to move this over here. We've got all this real estate over here. 4 equals 2x. I'm going to divide both sides by 2 and by 2. Okay, and so I get that x is equal to 2. Okay, so now here's what I got. All right, I know that x is equal to 2. I also know from this problem that y is equal to 7. So what I have is I have the ordered pair 2, 7. All right. Now what I'm going to do is I'm going to verify this graphically. Okay. So I've done the following. Okay. Use substitution to create a one-variable linear equation. Okay. I took 7 and I substituted it in for y. I solved to determine the value of the unknown variable, which is x. Okay, so I solve for x, and then I wrote my solution. Now what I'm going to do is I'm going to verify this solution. Okay, now what I want to do is graph both of these equations. Okay, now when I graph the line y equals 7, that's a horizontal line through 7. Okay, and that's that graph. Okay, the other one, on this equation, I've got a y-intercept of 3 and a slope of 2. So I'm going to plot my y-intercept of 3, and I'm going to do a slope of 2. So I'm going to go up 2 over 1, up 2 over 1, and that's where these two lines intersect. Down 2 to left 1, and so on, okay? And I'm just going to draw my line to connect these, okay? Now what I'm looking for here is my happy place, okay? And this is the point 2, 7, all right? And that's how we do that. But the idea here is to, take a look at these, plug these values in, do the substitution, and algebraically solve for x, and then you already have your y, okay? All right, now let's do this. I'm going to do the exact same thing over here. And let's go ahead and just graph this one first, okay? So, now let's do substitution first, all right? And I'm going to write this out over here. I've got y equals negative 1/4 x, what is that, minus 2? Okay, and I've got x is equal to positive 4. Now what I'm going to do is I'm going to plug in 4 into x of my other equation. Okay, so I'm going to rewrite my top equation, y equals negative 1/4 times positive 4 and then minus 2. So what I've done is I've replaced x with what x was equal to. X is equal to 4, so I plug that in up here. So y equals negative 1/4 times 4 minus 2. Now what I'm going to do is I'm going to multiply these two numbers together. Now in order for me to do that, I want to have negative 1/4 times positive 4 over 1 and then minus 2. So I'm going to multiply across. So I got negative 1 times 4, which is negative 4. 4 times 1, which is 4, and then minus 2, and that's what's equal to y. So to continue doing the math, okay, I've got y equals. Now negative 4 divided by positive 4 gives me negative 1. So I've got negative 1 minus 2. All right, and so then negative 1 minus 2 is just negative 3. So I've solved for y, and that's equal to negative 3. So I have my solution here as x equals 4, okay, and then y equals negative 3. So that's the point, 4 comma negative 3, and that's my solution, okay. Now I'm going to come over here, and I'm going to graph this, okay. The line x equals 4 is a vertical line through 4. And let me do that. Boom. Okay, and then my other equation, negative 2, okay, is my y-intercept, okay, and then my slope is negative 1/4. So I'm going to go down 1, okay, and then over 1, 2, 3, 4. All right, here's my point of intersection. All right, and that's what I've got there. All right, down 1 over 4 again, up 1 over 4 again, and here is my line. Okay, so this again here is my happy place, and this is the point 4 comma negative 3, which is what we got algebraically over here. Okay, so that's the idea. So what we're doing is we're just plugging those values in and then seeing, you know, and then doing the algebra to get my other variable. Okay, let's take a look at the next page. Okay, so on this one, what we're dealing with on this is when we have substitution method with two variables. Okay, in this, I have two linear equations. Okay, I don't have one of the values already solved for. Okay, so what I'm going to do is, again, do the same thing. Use substitution to create a one variable linear equation, solve to determine the unknown variable in that equation, and then substitute the value of the variable into either original equation to solve for the other variable, write my solution, and then verify the solution. Okay, so here's what I'm going to do. Okay, what I have here is that both of these equations are solved for y. Okay, and what I'm going to do, it doesn't really matter which one you choose, but I typically choose the bottom one. I'm going to take this value here, 2x plus 9, and I'm going to substitute that entire thing into my y value of the other equation. So here's what I get. I'm going to get 2x plus 9 is equal to 6x plus 1. Okay, so what I have done is I have replaced y with what it was equal to in my other equation. Okay, so now what I have is I have one variable. I just have a single, I have x. Okay, I don't have x and a y. So what I'm going to do here is I'm going to solve this equation now for x, okay? And how I'm going to do that is I'm going to subtract 2x from both sides, okay? I'm going to get 9 is equal to 6x minus 2x is 4x plus 1. I'm going to now subtract 1 from both sides. So I get that 8 is equal to 4x. Divide by 4, divide by 4. 4's divide out, and x is going to equal 2. Okay, so what I have done is I have solved for x. Now, what I'm going to do is I'm going to resubstitute the 2, x equals 2, into x of one of my other equations. Okay, now I'm simply just going to plug it into the top one. You can plug it into either one, it doesn't matter. But I'm going to plug this in, and I'm going to rewrite this as y equals 6 times x. But instead of writing x, I'm going to write what x is equal to, which is 2. So 6 times 2, and then plus 1. So what I have is I have y is equal to 12 plus 1, and I get that y is equal to 13. So that's my y value. So I get the solution, okay, 2, 13, all right? Now what we're going to be doing is we're going to verify that these are our solutions, okay? So what I'm going to do is, to verify algebraically, is I'm going to substitute my values in, okay? Now what I have is I have that x equals 2 and that y equals 13, okay? I'm going to plug those in. So I'm going to replace y with 13. So I'm going to get 13 is equal to 6 times 2 plus 1. So 13 is equal to 6 times 2, which is 12 plus 1. 12 plus 1 is 13, so I get that 13 equals 13. That's a true statement, so it works for that equation. Now, it's got to work for both, okay? So let's try it over here. All right, same thing, plug in 13 for y is equal to 2 times x. I'm going to substitute 2 in for x, so 2 times 2, and then plus 9. So now I've got 13 is equal to 4 plus 9. So 4 plus 9 is 13. 13 equals 13, and that is true as well. So it works for both. So since it works for both, it's a solution, okay? All right, let's take a look at the next one. Substitution method with parallel lines. Now, here's what I've got. I want you to take a look at something, okay? I want you to see that because I have, remember parallel lines, okay, means I have no solution, okay? So that's something we got to make sure that we consider here, okay? Now what I'm going to do is I'm going to do substitution here, okay? And I'm going to do what I had done before. I'm going to take my bottom equation and I'm going to substitute that into the y value of my top equation. So I'm going to rewrite y up here with what it's equal to down here. So I'm going to write 3x plus 1 is equal to 3x minus 3. Okay, now I'm going to solve this equation for x, just like I had in the other problem, okay? So I'm going to subtract 3x from both sides, minus 3x, and then all of a sudden, look at what happens, okay? 3x minus 3x is 0, and that's going to cancel out on both sides. Now look what I have. I have the statement that 1 is equal to negative 3. This is a false statement, okay? And so because this is a false statement, there is no solution that will work for x. So what I need to write is that there is no solution, okay? So what I know from this is that, you know, if this happens, okay, if you get a false statement, and let's write this down here. So if you get a false statement, okay, then there is no solution. Okay, and that's what we've got. Okay, let's take a look at the next page because that has an entirely different problem, but very similar. Okay, so on this page, what you have is you have analyze a system of equations in which the slopes and y-intercepts are the same. So notice how you have two of the exact same equation. Notice how when you graph them, you only have one line. And that's because both lines are directly on top of each other. So what you have to look at just graphically is that when the lines are on top of each other, how many points of intersection do they have? Okay, and this would be infinite solutions. Okay, infinite solutions. All right, and let's take a look. Algebraically, let's solve this problem. Okay, I'm going to substitute 1/2 x plus 2 into y of my other equation. So I'm going to write 1/2 x plus 2 is equal to 1/2 x plus 2. Now what I'm going to do here is I'm going to subtract 1/2 x from both sides. Okay, combine my like terms. What happens here is that this is going to cancel out and add to 0. Same thing over here. And you're left with the statement that 2 is equal to 2. Now this is a true statement, okay? So because this is true, it lends itself to having infinite solutions, okay? And that's what we've got, okay? So if, okay, so if you get a true statement, then you have infinite solutions. Okay, so guys, all we're doing here is solving these like we had in the other sections, but we're doing it algebraically. Okay, and so this method of substitution is what we're using. Okay, so that's all I got for this video. Hope you enjoyed it. We'll talk to you soon. See you later. Bye.